So what is scientific notation? Well, scientific notation is an easy way of expressing really, really big numbers or really, really small numbers. And it allows us to compare numbers by making them an easy way to read without losing track of all the zeros. Very large numbers and very small numbers can be converted into scientific notation to express them in a more concise form. Now, since in chemistry we're going to be dealing with really large numbers because there's lots and lots and lots, billions and billions of molecules in chemicals equations, we have to be able to really, really hone in on this skill. Numbers expressed in scientific notation can be used in a computation with far greater ease because all we have to do is multiply a couple numbers together. Scientific notation is a very easy way to express large numbers. However, it has a basic form. First of all, it has a base number, and the base number is only one digit in front of a decimal. So therefore, it has to be a number greater than 1, but less than 10. It also has times 10 to an exponent. So therefore, here is the actual notation on how to write it. Here's the form. N is your base number, and it's between a number greater than 1 but less than 10, and again it probably is going to be a decimal number, times 10 to an exponent. So, in order to make a number into scientific notation, first of all, you have to place the decimal point so that there is only one non-digit number left of the decimal point. Then you count the number of decimal places that you moved from the original number. This will be the exponent on the 10. If the original number was less than 1, then the exponent is a negative. And if the original number was greater than 1, then the exponent is a positive. Here's an example. Given this number, what you do is you figure out your base number first. And your base number has to be greater than 1 but less than 10. So therefore that number is 2.898. Okay? And it's always written times 10 to some exponent. And that some exponent has to do with how many decimal places we move it. Now, since this number is greater than 1, the exponent is going to be greater than 1 as well. Okay? So, 1, 2, 3, 4, 5, 6, 7, 8. So therefore, it's 2.898 times 10 to the 8th power. Here's an example for you to try. Go ahead and pause the video and try it yourself. Okay, so if we have this number here, again we have to figure out a number between 1 and 10 and place a decimal place. Okay, so our base number is 5.67. Now we have to figure out times 10 to some number. And it has to do with how many decimal places I move it. Okay, so I move it 1, 2, 3, 4. Okay, now since this number is less than 1, it's times 10 to the minus 4. Anytime you see a negative sign on an exponent, that means the number is less than 1. And if it's a positive, it's a number greater than 1. Alright, now we're going to go the reverse. So So basically, given a number in scientific notation, how to change it back to regular form? Well, it's basically the same concept, except you're just going to be moving the decimal place. Simply move the decimal point to the right for positive exponents, and obviously if it's a negative exponent, then you move it to the left. And any places that do not have zeros, you place zeros to fill those spots. For example, given this number, we are going to move the decimal place 6 times to the right. So 1, 2, 3, 4, 5, 6. And any place where there's a missing space, you put a 0. So therefore, the number is 5, 0, 9, 3, and 3 zeros. 1, 2, 3. So this number is 5,093,000. Here's another example. Now, you'll notice that the number has a negative exponent. So therefore, you're going to be moving the decimal place to the left. Okay? So I'm going to do it up here. 1.976. I'm going to move it to the left 4 spots. 1, 2, 3, 4. And again, you fill in the zeros and the missing spaces. So it should read 0.0000, 3 zeros, and 1976. Okay, now your scientific calculator can actually be programmed to use scientific notation, okay, in calculating really, really large numbers or really, really small numbers, okay? There's a couple things that you have to do, and I will show you how to do this in class, but let's just use it as a review. So you punch in your number, okay, your base number into your calculator. Then you press either this EE button or the exponent button. Do not use times 10 button. It doesn't work. The EE button means it's times 10 to some exponent, okay? Just like scientific notation. Okay? And then you press in your exponent number and you use the plus or minus button to change its sign. So, on a Texas Instrument, it's this button here. Okay, on a Casio, it's this button here. But most people have this Texas Instruments, and what you actually have to do is press the second key and then this button, the little comma, and you'll see the little EE above it. So what I want you to do is I want you to multiply these numbers, and this is how it should read on your calculator. 6 E 5 times 4 E 3. And what you should get on your calculator is 2.4 times 10 to the 9th, or 2.4 E 9. Here's another example. Go ahead and try it.